All right, welcome back for Chapter 3, Exponents and Roots, and today we're discussing Lesson 4, Operating with Scientific Notation. So operating, that word, what that means is we're going to be learning how to divide and multiply, add and subtract numbers in scientific notation. All right, so what this says is you can use the properties of exponents to multiply and divide numbers expressed in scientific notation. So let's see how that works. So we have this right here with example 1. So this is division with scientific notation. 1.8 times 10 to the 14th divided by 4.6 times 10 to the 9th. So that looks like this. And instead of using this division symbol, I'm going to use this division symbol. And when we have this, right, what we really have is two division problems. This is all one big division problem, but I like to look at this in sections. And so the first section that we can look at is right here. This 1.8 divided by 4.6. So we just need to figure out what that is. What is 1.8 divided by 4.6? And then we can look at this right here. 10 to the 14th power divided by 10 to the 9th. And if you see here, we have the same base as 10. We have the same base, and it's division, so we can use that quotient rule. Now, the reason why we're able to do this and look in kind of two separate things is because everything is multiplied and divided. So we have 1.8 multiplied by 10 to the 14th power divided by 4.6 times 10 to the 9th power. And if we look back at our order of operations, right, which was, please excuse my dear Aunt Sally, parentheses, exponents, multiplication and division. Everything here is multiplication and division. So that means it doesn't really matter the order in which we do things. So I am just kind of changing up the order, right? Initially, this is like 1.8 times 10 to the 14th, but I'm going to just divide these numbers and then divide these numbers into parts. And you can do that because they're all in the same level in the order of operations. So let's go ahead and try this first. So 1.8, I'm going to go over here. This is going to be my little side paper. 1.8 divided by 4.6. Now, whenever you're dividing by decimals, you have to remember you can never divide by decimals, right? So I have to move this over one place, and if I do that here, I have to do it here. So we really have 18 divided by 46. We're just going to say, okay, how many times does 46 go into 18? Well, none. So we have to add another 0. 46 goes into 180. How many times? I'm going to think about this as 50. So 50 would go into 180 about 3 times. 3 times 6 is 18. Write the 8, carry the 1. 3 times 4 is 12, plus 1 is 13. Okay, then we subtract. I need to borrow here. That would be 2. 7 take away 3 is 4. Okay, so that's less than 46, so we did it correctly. I'm going to add a 0 and drop it down like it's hot. 46 goes under 420 how many times? I'm going to think about 46 as 50. So 50 goes into 400 8 times. If it was 9, it would be 450. So I think it's going to be 8. 8 times 6 is 48. Write the 8, carry the 4. 8 times 4 is 32, plus 4 is 36. Right? We subtract. 10 take away 8 is 2. 11 take away 6 is 5. Oh, it can go in one more time. That's bigger, so it should be a 9. Okay, where's my friend? So what was this? This was 420. This was 420. It goes in 9 times. Okay, 9 times 6 is 54. Write the 4, carry the 5. 9 times 4 is 36. 36 plus 5 would be 41. Oh, okay. Then we have to borrow, and we have 6 and 0 right there. And 46. Oh, I dropped that 0 down, didn't I? 46 goes into 60 one time. And we would subtract. That would be 5, that would be 1. And does it go in 3 times or 2 times? Maybe 3. 3 times 6 is 18. 1, 3 times 4 is 12, plus 1 would be 13. Okay, draw, subtract, and that's it. Remainder of 2. So I think I'm going to just stop right here. Hold on a second. Well, that's not working. Hold on. 18 divided by 46. Yeah. Okay. So we're going to stop right here. So that means that this ends up equaling 0.3913 times 10. We have the same base. Quotient rule just says you subtract the exponent. So we have 14 take away 9, which ends up being 0.3913 times 10 to the 5th power. Okay, so this is what we end up with right here, okay? Now, is this in scientific notation? And you have to check, right? So this number here is supposed to be between 1 and 10. So the question is this number between 1 and 10? And the answer is no, it's actually less than 1. So we need to make this number bigger, right? So how are we going to make that bigger? Well, we're going to make it bigger by multiplying it by 10. So we really need to take this number, 0.3913, and we need to multiply it by 10, right? And because we already have this times 10 to the 15th. So this is this number here, right? And then 10 to the 5th is right here. So I'm just multiplying this number by 10, and what will happen is when I multiply this number, it's going to move one place over, and it's going to become 3.913, which is exactly, that's between 1 and 10, that's what I need, right? But I can't just multiply something by 10 and have it be the same thing. So if I multiply it by 10, I am also going to divide it by 10 at the same time. Except what's going to happen, this multiply by 10, because what is 10 divided by 10? 10 divided by 10 is 1, and I can multiply any number by 1 and it remains the same number, right? So this is 10 divided by 10. It doesn't, this is the same 1. So what I'm going to do is I'm going to be tricky. This part of the 10, I'm going to use that to multiply here. And then this part, this divided by 10, that's going to go here. So 10 times 0.3913 ends up being 3.913, right? Times 10 to the 5th divided by 10, right? And what's the exponent here? The exponent is 1. Okay, so I just have a little quotient rule. So I write this 3.913 times 10. I have the same base, 5 minus 1, which ends up being my answer, 3.913 times 10 to the 4th power. And that is my final answer. So the key to this problem is first writing it as a fraction, solving it in 2 parts, right? We just do this and then we do this. And then after we do that, we have to notice if this number is between 1 and 10. And if it's not, this number was less than 1. So that means we had to multiply it by 10 But if we multiply by 10, we also have to divide by 10. So we multiply this number by 10, and then we divide the powers by 10. When we multiplied it by 10, we ended up having 3.913. When we divide by 10, then we go to quotient rule, and there we have our answer there. Perfect. Okay, let's go ahead and try another one here. So the first thing I'm going to do is go ahead and rewrite this problem. So as a division problem, or as a fraction. Okay, so I'm going to kind of separate this, right, and do this part first, followed by the quotient rule here, because we have those same bases of 10 again. Okay, so I'm just going to go 4.2 divided by 1.4 first. So 4.2 divided by 1.4. Whenever you're dividing by decimals, you can never divide by decimals, so I have to move it over one place, and I have to do the same thing here. So it's really 42 divided by 14. How many times does 14 go into 42? I'm going to kind of think about that as 15, 15, 30, 45. It might go in exactly 3 times. 3 times 4 is 12, right? The 2 carry the 1. 3 times 1 is 3 plus 1 is 4. So it goes in exactly 3 times. Ooh, this is so nice. Okay, so 4.2 divided by 1.4 is 3 times 10 to the, and we do the quotient rule, 7 minus 5 ends up being 3 times 10 squared. And that is our answer. This number is between 1 and 10, which is perfect. And yeah, scientific notation. So how about you try C? Okay, so I want you to, here's my friend the pause dragon, remind you to pause your device, work out C. When you get done, press play and we'll talk about it together. All right, see you in a bit. All right, let's see how you did. I'm going to start by rewriting this problem as a fraction. Okay, the first bit is this. I'm going to divide it into 2 parts, right? And then the second part is that quotient rule. We can use the quotient rule because we have the same bases. It's that cheat rule whenever they have the same base and it's division. So first I'm going to take this and do this division over here on the side. So we have 4.56 being divided by 1.2. Whenever you're dividing by decimals, the first thing is you can never divide by decimals. So I'm going to get rid of the decimal by moving this one place, decimal place to the right. If I do that here, I also have to do it here. So I end up with 45.6 divided by 12. 12 does not go into 4, but it does go into 45 3 times. 3 times 12 is 36. We subtract, and that is 9, and that's just 9. Okay, decimal goes here. Does 12 go into, oh wait, this is less than 12, so that's good. So then I need to drop this down. Does 12 go into 96? It does, and I want to say that I think it goes in 8 times. 8 times 2 is 16. 8 times 1 is 8 plus 1 is 9. So perfectly. Ooh, this is so fun. Okay, so this is 3.8 times 10 to the 17 minus 8. And I want to see all of this work. Whoops, sorry about that. So we end up with 3.8 times 10 to the 9th power. And this number is between 1 and 10. And this is a power of 10, so we know that we have our answer in scientific notation. Woohoo! All right, let's go ahead and look at how this is applied in a couple different story problems. So here we go here. It says D. About how many times greater is the mass of Jupiter than the mass of Earth? Write your answer in scientific notation. Okay, so when we're doing a problem like this, we have to put the mass of Jupiter, this is a fraction, mass of Jupiter over the mass of Earth. So it goes like this. Mass of Jupiter over the mass of Earth. Okay, so what is the mass of Jupiter? Well, the mass of Jupiter is 1.89 times 10 to the 27th power. divided by the mass of Earth, which is 5.97 times 10 to the 24th power, right? And we're going to do this in 2 steps. So we're going to do this portion first, followed by this portion here. Okay. So I'm going to go over here to the side. All right, so we're going to go, actually for this one, because it's getting really complicated, I'm just going to use my calculator to figure out what this is. So 1.89 divided by 5.97. And what I end up getting is this right here. So I end up getting 0.31658. I think I'm going to have this 8 round that 5 up to 6. So there we go. Times 10 to the 27 minus 24. Okay, so we end up with 0.3166 times 10 to the 3rd power. Perfect. Okay, now the question is, this kind of looks like scientific notation, but is this number between 1 and 10? And it is not, right? So does this number need to get bigger or smaller? It needs to get bigger. In order for us to get it bigger, right, we're going to have to multiply this number by 10. So 0.3166, I'm going to multiply this number by 10, right, times 10 to the 3rd, right? This is here and this is here, okay? I'm multiplying this number by 10 to make it bigger so that the number is between 1 and 10. But I just can't multiply any number by 10 and it be the same thing. So if I'm going to multiply it by 10, I also have to divide it by 10, because 10 divided by 10 is actually equal to 1, and I can multiply any number by 1, and it's the same thing. It's just in a different form, okay? And in mathematics, this happens a lot. Like, for example, 4 is equal to 3 plus 1, right? It's the same thing. It's just in a different form, or 4 is the same thing as 2 times 2. So sometimes when I'm referring to 4, I might write 2 times 2, or I could even write 2 squared, but it is the same thing as 4. It's just in a different form. That is the same thing here. This number right here is the same thing as this number, even though I have this times 10 divided by 10, because 10 divided by 10 is 1, and you can multiply any number by 1 and it's the same thing. However, this 10 right here is going to be multiplied by there, and then this divided by 10 is going to be applied right there. So we're kind of putting it in 2 different spots. So we end up with 10 times that. It moves over 1 decimal place, and I'm left with 3.166, which is now a number between 1 and 10, which is wonderful, times my original 10 to the 3rd, but now I'm dividing it by 10, okay? And there's going to be a little 1 on that exponent there, which leads me to 3.166 times, and we have the same base, so I'm doing the quotient rule, 10 to the 3 minus 1, which ends up being my final answer of 10 squared. Woohoo! Perfect. There we go. So now it is your turn to try problem E. So I'm going to give you some time. Here's my friend the pause dragon, reminding you to pause your device. Go ahead and work out problem E. When you get done, press play and we'll talk about it together. All right, see you in a bit. You can do it. Okay, we are back. Let's see how you did. So it says Pluto was demoted from planet to dwarf planet in 2006, in part because of its small size. The mass of Pluto is about 1.3 times 10 to the 22nd power kilograms. About how many times smaller is Pluto's mass than Earth's mass? 5.97 times 10 to the 24th power. Okay, so we are going to have the bigger mass on top, so it's going to be Earth's mass over Pluto's mass. And that's going to be 5.97 times 10 to the 24th divided by Pluto's 1.3 times 10 to the 22nd. Okay. Uh-oh. All right, so yes. All right, so we're going to do this in two parts, right? So this first part is here, and the second part is here that has the same base. Okay, so I'm just going to use my, when it starts to get complicated, I'm just going to use my calculator for this part. So 5.97 divided, oh my goodness, 5.97 divided by 1.3 equals, okay, 4.592. We'll just round it to there, to 2, times, we have the same base, 10 to the quotient rule would be 24 minus 22, which just ends up being 4.592. This is a number between 1 and 10, so we don't need to do anything. This number is perfect, times 10 squared. There we have it. So if you got that right, yoku denkimashita, you did a wonderful job, and I'll see you in a little bit for the next example.